Here we go. So we're going to do chain rule today. I'm going to give you a variety of problems, but I'm going to start off with each and every one of them. So we've done power functions to death now. We've done to the power of positive powers, negative powers, and then rational powers. We're now going to work through each and every one of these examples, and you'll see the pattern is that you just need to know these steps. Okay, so let's go. I'm going to do an example. So say you get an exponential function. So you could get something like y is equal to e to the power of, and we're going to make it nice and easy for the moment, 3x. Okay, so looking at your rules, the rule that I gave to you is something like this. If your function is e to the x, then the derivative, so delta y delta x, is equal to e to the x. This is the rule that you're using. All right. What do we have? We don't have x. We have 3x. Okay. So in this case, you can't apply this rule because you only need a variable x according to that rule. Okay. Just like your power rule, you can't do it when you have multiple terms. You can only do it when it's one variable, right? So same thing here. I can't do this problem unless I use chain rule. So here we go. The problem is I don't like that 3. That 3 in front of the x is a problem. So I'm going to replace this. So in chain rule, we introduce a new variable. We say, let's call this u. So let u equal to 3x. How does this change our problem? Well, our problem now becomes y is equal to e to the power of the letter u. Okay? So by doing that now, I can draw comparison, and I can say, well, if that's e to the x, delta y delta x is e to the x. That means here, delta y delta u has to equal to what? What is it equal to? What was that? The same thing, e to the u. So you would have e to the u as well, and that was the beauty. We can differentiate it if it wasn't 3x. But remember, we made that up. We introduced a third variable. So here, we need to figure out what delta u and delta x is. What is the derivative of the variable we just made up? We just said u equals 3x. The derivative of 3x using power rule, what's the derivative of 3x? 3, very good. So, now putting them together, we know that the rule says in chain rule, delta y delta x, which is what we wanted, is equal to delta y delta u multiplied to delta u delta x. So if that's true, well then this is what I'm getting. I have then e to the u multiplied to 3, and that gives me 3e to the u. But remember, you don't leave your variables in terms of u since this is delta x. So since we know u is equal to 3x, we're now replacing that, and we say it's 3e to the 3x. Now, most students will be okay with this problem if they use their textbook. The textbook rule says this. If you have e to the kx, delta y delta x is equal to k e kx. So it works. In your textbooks, when you do the questions, you'll be fine when, and notice, that's a linear equation. See, the derivative doesn't matter what k is. If that was 4, 4x becomes 4. If that was 5x, it becomes 5. If it was 6x, it becomes 6. So that problem works in your textbook. But in year 12 and year exams, they don't give you that. They don't give you a linear equation. And so then this rule becomes a problem. This rule assumes that k value that you have there, that k is the result of deriving a linear equation. Okay, and so that's why I don't like textbook teaching you this way, because when you get a problem that all they do and all they change is something like this, where they might say, what if you have e to the power of 3x to the power of 4? Suddenly students can't do this. Okay, so most students will then write, the answer is delta y delta x must then be 3e 3x4. And that's where they're wrong. Okay, because they're following this rule. And that's why I don't like teaching that way, because it works in year 11, but it won't work in year 12, and you're losing on understanding that the reason why you have the k there is because delta u, delta x is always a constant. But that constant is only true because kx is a linear equation. So when you use chain rule, of course it's always going to be k. But if it's not a linear equation, in our case that I just gave you, that's an x to the power 4. The answer will be different. Okay, and that's why I want you to make sure to follow the steps that I'm teaching you here so that when you're using chain rule, you're not going to make that mistake. So if we were to do this correctly, let's do this correctly. Okay, so I'm going to do it. This is the wrong answer. Let's do the correct answer. So if this is our problem, y equals e to the power of 3x to the power of 4. According to our rules, out of the 6 rules I gave you, the only thing we know is that when it's e to the x, derivative is itself, e to the x. I don't have that. This is the problem. I don't want that. That 3x to the power 4 is what I don't want. So what am I going to do? I'm going to use chain rule now. I'm going to replace it with another variable so it makes my life easier. So here we go. I'm going to say let u equal to 3x to the power 4. That changes this problem to now y is equal to e to the u. See, that is much more similar to this problem. And I'm like, okay, well, the derivative of e to the u has to be itself. E to the u, that was easy. Now I just need to figure out delta u, delta x. So let's work it out. What's the derivative of 3x to the power 4? What was that? Very good. That is 12x to the power 3. So using power rule, I've now got delta u, delta x. So putting them together, delta y, delta x has to equal to e to the u, so that's your delta y, delta u, multiplied to 12x cubed. So when you put it together, your answer should be 12x cubed e to the power of 3x to the power 4. Can you see the difference between the answers that most students would put? This is the answer that you'd get typically at the end of year 12 when they don't know how to do the chain rule versus this. So it works all the time when it's over here. It doesn't work when it's x to the power 4 because it's not linear. So when you find the derivative of 3x to the power 4, there should be that 12x cubed, not just 3. Okay, and that's why I don't like that textbook formula. And if you go to your year 11 formula sheet or a year 12 exam sheet, they will give you this. They won't give you what I've just given to you. Okay, so it's on you to understand that this rule comes about from a chain rule problem, and there's an assumption that the power is always going to be a linear form. Okay, so that's why I'm going to delete this, and I don't want you to copy that. And so that's why the 6 rules I gave to you, you've got e to the x, sine of x, cos of x, log e of x, all of them, you keep it as it is. Okay, anything that looks different from that rule, you use chain rule. Okay, let's do another one. So that was an example of how to use chain rule for an exponential. Let's do a sine, cos, tan, and logs, right? I'm going to write up all 6. Actually, all 4 left now. So let's do A. I'm going to give you, how do you find the derivative of, say, 2 sine of 4x squared? Okay, so I've given you a sine problem. B. Let's do a log problem now. So I'm going to do log e of, I'll do a typical one that students get wrong. X over 2. Okay. Yeah, we'll do that. And then let's do a, I'll just do it. Function notation. Ooh. So you would have to write, if you wrote f of x is equal to, let's just do the log e of x squared, right? Then when you do the derivative, you have to know that you're saying let g of x equal to x squared, and therefore you are finding the derivative of, so you're making it up. That's a new variable. So you know how we normally say let u equal to x squared? Now I'm saying let. Correct. So f of g of x, the derivative, okay, is essentially what you're trying to do when you find delta y, delta u. That's the equivalence. But I'm iffy in teaching you that notation at the moment because it gets confusing. That's why I'm starting off with y's. But later on, this is what the examiners will put into your multiple choice sections. And that's why you need to know how to read notations. Okay? But first get used to the y notation so that you don't get too confused when we start moving to function notation. Okay? So, what was the other one I haven't done? So we've got log, sine. Let's do a cos one. So let's do negative cos of, I don't know, let's do x cubed. Okay? There we go. So these are chain rule problems. Now I'm going to write the rules for each one for you. Remember, if the y is equal to sine of x, then the derivative, delta y, delta x, is cos of x. If you have log e of x, the derivative, delta y, delta x, is 1 on x. If you have y equals to cos of x, the derivative is the negative of sine of x. Okay, so that's the only thing you've got. Your aim is to use chain rule to get to this. You just need cos of a variable, sine of a variable, log e of a variable. Anything that looks different from that, you have to use chain rule. Okay, so I'm going to do the first one. Let's do the first one together. Let me just move this away. Here we go. So, if I'm going to do this sine one, the 2 doesn't matter because remember the 2 is a constant, so it's 2 times. I'm trying to find the derivative of sine 4x squared. But according to my rule, I've only got sine of x. So, that's a problem. There's a problem here that I can't do. I can't do sine of 4x squared, but I can do sine of x. So this is where chain rule comes in. Chain rule looks at, okay, well, what can I replace? And I can replace this 4x squared, and the traditional variable we use is u, the letter u. Okay, you can use any other variable you want, but traditionally use u. So we say here, let u equal to 4x squared. If we were to now find the derivative, the function now becomes y equals to 2 sine of u. Because I replaced the variable. I said let u equal to 4x squared. Now I have y equals 2 sine of u. So here, how do I find the derivative? Well, same thing. Remember, the 2, you don't need to derive. You only need to derive sine of u. Now, based on my rules, if y equals sine of x, the derivative of that is cos of x, then what's the derivative of sine of u? Derivative of sine of u must then be cos of u. Okay, so here I can write cos of the letter u. Okay, so I've made my problem easier because I've replaced the 4x squared with a third variable. Okay, so here I've got delta y, delta u. Delta y, delta u. Now I'm trying to find what is delta u, delta x. And thankfully, 4x squared is a nice power function. So again, derivative of 4x squared has to be 8x. Very good. So together, what is my derivative? Delta y, delta x. According to chain rule, I am doing the multiplication of 2 cos of u multiplied to 8x. That gives me 16x times cos of, and the letter u can be replaced with 4x squared. This is my answer. Okay, so the derivative of 2 sine of 4x squared is 16x cos of 4x squared. Okay, you've seen the method? It's always the same. And one of the key things to pick up, how do you know when you have a chain rule? It's literally a function within a function. You can see I've got a function of sine. What's inside that? A quadratic. Okay, I've got a quadratic within a sine. Over here, notice I've got x, but that's x over 2. That's a linear function within a logarithmic function. That's when you use a chain rule. Okay? Let's try another one. Here we go. I'm going to move this away so I get more space. There we go. All right, let's do number 2. Let's do B now. I'm just going to show you that so you can still see it. Let's do B. You can have a go ahead of time if you want. B is common mistakes because of fractions. Students aren't good with fractions. They don't like fractions in general.
Sorry.
So ungrateful. So here we go. Same thing. Let's look at this problem. Y equals log e of x over 2. I can't do it because all I can do is when it's x. Right now I've got x over 2. So this is where you then have to replace the x on 2. That's what I'm replacing. It's a function within a function. So here I would then say let u equal to x over 2. And then that means my new equation now becomes y equals to log e of u. I can now then use my derivative. So delta y delta u has to be, based on my rule, the only difference is the letter of the variable, so it should be 1 on u. Out of curiosity, sometimes this actually gets students as well. What's delta u delta x? Because most students can do it when I give you 2x, but when I give you x on 2, whatever reason, it gets students a bit. It's a half, yeah. Another way of looking at that, if you're unsure how to do that, this is the same thing as writing half times x. Okay, so when you write half times x, it's the same thing as x divided 2. So if you prefer, this look might help you. Okay, it's just like however you did with 2, it's the same thing with a half. Okay, so the answer, yes, the answer should be half. And so now let's put it all together. What is my rule? My rule says delta y delta x is equal to delta y delta u, which is 1 on u, multiplied to delta u delta x, 1 on 2. Let's put the answers together. U was 1 over, and this is where students make a mistake in year 12. They usually make a harder type of problem, but you can see what happens here. See, the letter u was x on 2, so you're replacing that u with an x on 2, and this is what students struggle with. When I ask them, what is 1 divided by x on 2, that intimidates some students. Basic algebra here, like all fraction skills. Versus times half, they're okay with the times half. They're struggling there. What is 1 over x on 2? What's that simplified as? 2 over x. Very good. For those who don't know how to do it, this is the same thing as saying 1 divide x on 2. If you write it like that, it's much easier to digest. Division of fractions, we know we do the reciprocal, so it becomes 2 on x times 1, so it is 2 on x. Okay, so I'm just going to go back here. This should be 2 on x times half, and that gives you 1 on x, because 2 divided by 2 cancels out to be 1. Okay, there is a rule in your textbook that essentially summarizes that. They say y equals to log e of, doesn't matter what the value of k is, k times x, then the derivative will be 1 on x. Again, the reason why I don't like teaching this to you is because it only works, that's a linear equation. Okay, so if it's kx, if it's not a linear equation, it's not going to work, and students will stick to 1 on x because they memorize it. Okay, yep.
If that's a variable in front of a number in front of log, where in the equation would that go?
Yep, so if there was a number, so say I put the number 3 here, then when you're finding the derivative, the 3 would have been here, and it would have been 3 times 1 on u, and that would have been 3 over u. And that would have been 3, 3, and then the 3 would have been times 2, and then the final answer would be 3 on x. Yeah. Okay, I'm just going to rub that out in case it confuses people. All right. I feel like you've got quite a feel of it at the moment. I want you then to have a go with number C now. Let's try C. And then I'm going to get you to do your worksheets, the worksheet I've given you with that same practice. You've got your 6 rules. Follow the same steps I've just given you. And then I'm going to look for some Year 12 exam questions. I'll pick maybe 3 and see if you can have a go. Okay, because that's all you need. Chain rule, the 6 rules. You should be able to do a Year 12 exam 1, question 1, 2 marks. Okay, that's 2 out of 40 marks. So that's about 1/8. Is that? Wait, no, 2 out of 40, 1/20th. There you go. 2 marks. Doable. Okay, very doable. Exam 1 of methods for next year is always designed for you to get marks. They're giving out pity marks. Okay, so if you can't do exam 1, then you're below the average. Okay, exam 1 was designed that if you were to get a 40 on, a 40 raw, you'd be expecting to get an 80% easily. Okay, 80% is like your standard. If you're not getting 80% for exam 1, it's a very big indicator you're hitting in the average zone, about 30 or so. If you can't do the first page of the first exam, then definitely I will predict that you're sitting at about the 25 or below. Okay, so that's how I know. It's just based on your algebra and derivatives. Have a go with this one. So I'm asking you to find what is the derivative of y equals negative cos of x cubed. The one in red tells you the rule. That's my derivative rule I've given to you.
Derivative of e to the power of x is function notation. Alright, let's see. You are writing, so this thing f of x equal to font encryption. It's just font encryption.
Encryption just turning plain text into ciphertext. The text is basically
Derivative. Dash. What's penetration testing? Who does now? What would be the function?
penetration testing.
That's really wrong. It's
when you try to test every part of your software, you're trying to test like all the user inputs to test for vulnerabilities like SQL injection, scripting, and all the like DDoS attacks and all that. And it can be performed by a professional or can be performed by like a software.
It's performed by a surgeon. So that would be
Wow. Yeah, professional.
actually is that right? What's insecure cryptographic storage? No, so it's when data is stored inappropriately or illegally. Insecure cryptographic storage. There's definitely going to be a question about that. They're just like sneaking in like very well marks.
They gave you f of x.
Right, what's
That's true. So let's go back.
Let's pop
say
up.
that because I think this is how I usually see it.
When like when you like add too much stuff, too much data into like a block it exceeds like the storage of the
Where I can essentially notation the drop files.
That's an alright answer. It's acceptance of that function.
it's like relevant.
Let f of x equal to
What are the 4 types of threats relating to integrity of data?
Technical, academic,
Define data integrity. No, just data integrity. What's data integrity?
Okay. So it's like characteristics of data integrity is like correctness, accuracy, reasonability.
It's not the characteristics. What is data security?
Security or integrity?
Integrity, sorry.
Integrity. basically if the data can be trustworthy, whether it's correct and has true details, and if data can be trusted by authorities and manipulations can be trusted by.
I'll accept it. So if it was a day, I'll accept 60% is fairly fast. What are the two components that are like? Yep, I don't remember the years of researching Google.
Yeah.
So if you click what's the notifiable data breach?
Want me to explain what it
Yes.
is? Firstly, it's a federal act. Basically states that, all organizations, if they have a data breach, they have to announce it. It can cause significant damage.
Yeah, organizations and
Organizations.
and
This is when I say government organization, I mean governments as well.
you got it explicitly say government.
Whatever, bro.
Just and then switch pages. Yeah, we have a 2 hour session for that. Stay after school.
Yeah, it's so bad.
Tell them that
What is the vision statement?
Vision statement is basically it's a statement that allows people to understand the company's future.
Alright, mission statement.
Mission statement is like defining the terms.
You didn't say that. You did. That's exactly what I said. I would never say, hey, that's funny. This one is exactly what you said.
The statement states that you can't send any unsolicited messages.
But you can send unsolicited.
Yeah,
There's a certain type.
like repeatedly.
Right.
It's commercial. You can't send commercial.
Oh, yeah, okay, yeah.
And there's a few more.
Yeah.
A single one.
That's what I said.
The reason why
Then I just
you should just be doing
What's version control?
version control is basically makes sure you're trying to change or update your software so you can keep that in mind and make sure you have
It's not really backing up.
not really bashing up, like keeping like logs.
yeah, but then if you were
But version control is more like managing the changes to. There's like a master file, like all the branch files, and then you can merge, you can roll back. It's basically GitHub.
Yeah. I never use
Yeah.
GitHub. You can say the dash I remember.
Yeah.
His name is probably cheaper will get it.
Guys, did you find it?
But you can't see that.
Yeah. Tell me what a firewall does.
Firewall basically prevents from like attacks using your good
Good network.
Yeah.
Okay. But there's like true specific functions they do.
which one?
Firewall, they do packet inspections, so they check each packet that routes
yeah.
to the network, they check it on the malware, and they also do port logging, so they can log setting.
Yeah, 480, yeah.
Setting instead.
I don't know.
What's cyber criminal?
What did you do, guys?
Just like it's an attacker. How do you find someone? Like, it's such a basic thing. Like, someone who does crime online, yeah, like attacks people.
Alright, this one should be easier. Cyber terrorist.
Cyber terrorist, someone who's basically a cyber criminal, but with the with like malicious intent to like destroy stuff.
Destroy.
Yeah.
Yeah, but you can say like cause physical harm.
You just hate yourself.
Quite ideological.
Yeah. So they knew that was gonna come.
Alright, so give me one more.
One more.
Give me a hard one.
Hard one. Alright. What is
Oh, sorry, Tim. Just going to check if you got the correct answer. Here we go. Delta y delta x should equal to, hopefully you had 3x squared, which is your delta u delta x, multiplied to, oh, and don't forget that negative 1, times by negative sine of x cubed. So your answer should be 3x squared sine x cubed. Hands up if you got that correct. Oh my god, I got 0. 1. All right, we're on to something. I'm going to stop the video here, and I'm going to get you to practice the worksheet. So the worksheet I've given you, there's a range of different problems. The ones on the bottom are trickier. I only got enough for you. Oh, no. So on the bottom, the ones on the bottom here is where it's better.
It's a toy.
And there is a toy.
Yeah. Isn't it just a toy?
E-toy. Yes.
So you do that.
E-apple.
So does that mean? So is this question? Is this positive? Is this going to be positive?
Apple looks like that.
12 or negative 12?
But mine looks exactly like it.
D.
It looks like a really small head.
You're correct.
You can't make his
Because
head
the
bigger.
root of
I
sine is
can't.
equal to cos.
That's really cool.
Whereas the one I've got up there is
Where's the
double
toy?
negative.
Mine looks like
Negative.
this shit.
Negative 12.
Is it negative 12?
Why is that one a negative 12? Why is there a negative 1 in front of the times?
Because that, remember how I said like constants, they stay the same?
Yeah.
So that is a negative 1 there, so I kept the negative 1.
But isn't u just x cubed? So the negative wouldn't affect the u.
No, the negative doesn't affect the u.
Where does the negative 1 come from?
So, imagine I gave you 2 cos of x cubed, right? How you would have done it was you would have said this 2 stays as it is. Sorry, I should probably do it properly. So, if we called this u, delta u delta x would be 3x squared, so it doesn't get affected by that 2, right? But this is delta y delta u, and that becomes 2 stays the same. I just rearrange them, that's all. So in my mind, how it works for me is I deal with all the numbers first. So I do that, I keep the numbers, and then I derive cos by itself, is how I order it. But you can order it however you like, because by doing this, my answer will always have number, variable, function, is how I like it. But you can do it however you like. But that's essentially the 3 components to them. That's the coefficient, that's the y variable, the function that you had, and that's the one that's inside the function. Yeah. All right.
You get the same answer if you just thought of